moving back to chapter 6, just briefly, we skipped this topic because this way we can put it right next to the last one we did with exponential and logarithmic modeling. It's the exact same thing, only we're going to look at polynomials again. So, without too much preamble, let's look at our learning targets. One, I can use finite differences to determine the degree of a polynomial that will fit a given set of data. This is kind of like is it exponential or not? We're going to look to see, is it quadratic, cubic, quartic? We're looking at finite differences, so it's just adding and subtracting instead of the ratios that we were doing yesterday, which involved multiplying and dividing. And of the two learning targets, this is probably the hardest one. And the hard part is the subtraction. And you might be thinking, wait, no. Of all the things that we have done, I can handle subtraction. Let me know again in class when you're subtracting and you make a mistake and you can't figure out what it is. And it happens. It happens to pretty much everybody. And it's kind of amusing, but, we'll see. The second one, I can use the technology to find polynomial models for a given set of data. This is the regression. It's the exact same thing that we did with exponential and logarithmic models and quadratic models and linear models, except we'll be choosing cubic or quartic models. We will also be looking at comparing two different models as well. So I guess there is a little bit new there, but the steps are all the same. So determining the degree. The first thing we need is a set of data. Hey, look, there's a set of data. And just like with all of the sets we've had before, the x values have to be going up by the same amount each time. If they're not, then we really can't do much with it this way. We would have to graph it and look at the shape. And so, here though the x values are going up by the same amount, and so now we're going to look at the y values. The first thing we're going to find is the first difference. And this is something we've been doing since chapter 2. So the first difference, to get from 23 to negative 2, we subtract 25. To get from negative 2 to 1, we add 3. From 1 to 2, we add 1. From 2 to negative 5, we subtract 7. And from negative 5 to negative 2, we add 3. And again, those are our first differences, and they tell us whether or not this polynomial is linear. Now, we're looking for it to be the same, or really, really close to the same. This is not. So, no, it would not be linear. The next thing we would do, which we did in chapter 5, is we would find the second differences. The second differences are just the differences of our first differences. So to get from negative 25 to 3, we'd add 28. From 3 to 1, we'd subtract 2. 1 to negative 7, subtract 8. And negative 7 to 3, we'd add 10. And those second differences tell us whether or not it's quadratic. And so the first differences tell us if it's linear. That would be x to the first. The second differences tell us if it's quadratic. That would be x squared. The third differences will tell us if it's cubic or x cubed. And that pattern will continue until you run out of points. And we'll see that in a minute. But third differences. From 28 to negative 2, we're subtracting 30. Negative 2 to negative 8, subtract 6. Negative 8 to 10, we're going to add 18. So that's asking, is it cubic? Well, these numbers are not the same, so no, it is not cubic. Let's try the fourth differences. From negative 30 to negative 6, we add 24. From negative 6 to 18, we add 24. And all of a sudden, it comes together. And so that would be the fourth. That would be x to the fourth. That would be a quartic degree polynomial. Now, we could continue this to 5th degree, 6th, 7th, 8th, but we would need more points. Because if we went to the 5th degree, we'd only have one number, and you can't compare one number with nothing. You have to have at least two numbers to compare with. You don't really have to do that. Quartic is really as high as we're going to be going, but with more data, you could keep going like that. And so this one's quartic. And so that's how we find the degree. You can see all the subtraction in here and how we have positives and negatives everywhere. Yeah, people make mistakes in there. It's okay. It happens. If I laugh at you, I apologize, but yeah, that happens too. So the next thing is we're going to look at finding a model, which is the regression stuff. So let's get ourselves a data set. Here we go. And here, the x's aren't going up by the same amount each time. And so we can't use our differences with our y values to figure out what kind of data set we need. So we're going to have to graph it. And luckily, that's one of our steps anyway. It's almost like it's one of our steps for a reason. Even back before we really had to graph it, we were still doing it just to get into the practice. And so let's look at our steps. Our 5 steps. We're going to enter the data, graph the data, do the regression, which involves choosing the regression, and check the graph, and then answer the question. This one I didn't actually give you a question, so it's just find a polynomial model that represents this data. So step 5 we would already have done. So let's pull out our calculator and see what we're going to do. So the first thing we need to do is we need to enter the data. So we're still going to go to Stat, Edit, and oh look, I have my data from last time in here. So we can go up and clear it. Don't delete, clear. Go back down. Hey look, I cleared the list. Go over, do the same thing. Up, clear, back down. And now I'm ready to enter the data. I'm going to use my keypad so it takes a little bit less time, because doing this on the mouse is very slow going. I would have had it already entered, except I wanted to show you how to clear it. And so there's list 1, list 2's going. You might be wondering, wow, how can he talk while he's entering this data? Well, remember, I had to film this video before, and then it's just sitting there running, and I'm just narrating it as we're going. All right, data's entered. Next thing we need to do is we need to graph the data. So we're going to go up to second stat plot, choose one, probably the first one. Hey, it's already on. Chances are you've been doing this. It's going to be on. It's going to be set up for list 1, list 2. So let's zoom stat. You will have to do this every time. And there's our data. It's kind of crazy. It looks almost quadratic, but then there's a tail there. So maybe it's cubic. So let's try a cubic regression first. So back into stat, go over to calc, and then go down to cubic regression, number 6. And everything gets entered in here exactly the same as it always had. List 1, list 2, story regression equation, you can go y1, alpha trace, there's y1, calculate, and there's our equation. Now in our first one, our leading coefficient, we have 6.9 times 10 to the negative 4th. That really small leading coefficient is sometimes a little warning that, oh, maybe that one's not so good. But, still try it. Hey, we're going to graph. Hey, hits those 3 pretty nice. Misses that one. That one's all right. And hits that one pretty good. So that's kind of close. But let's try a quartic as well, just to check. So we're going to quit. Going to do the exact same thing. Go down to quartic regression, number 7. And we're going to put in the same stuff, except for this time story regression equation. Let's put it into y2 so that we can see them both at the same time. And you get through the same way as y1. Enter. Here we have an even smaller leading coefficient, but look at that r squared. The r squared is how close it fits. The closer it is to 1, the better. Then we can graph. And this is the first one that we saw, the cubic. It's going down. There we go. And now here comes the quartic. Nailed those 3. Ooh, hit that one. And that one. Oh, is it going to go for all of them? Nailed it. So that one's a really good fit. I mean, for a polynomial regression with just random data, that one's awesome. I would be willing to overlook the low thing, but being that it's a quartic, at some point it's going to keep coming down and then go back up, which, the model might not work back there anyway. So now if you forgot to write down the equation, you can always go to the y equals, and there it is, and it just lists out the numbers, and you'd have to scroll over to get it all. Or a lot of times when I do this, I'll do the cubic, I'll do the quartic, I'll graph them both, and then I'll see like, oh, hey, the quartic works better. I'll just do the regression again really quick. You don't have to worry about storing a regression equation, but do the regression, and that'll pop up with the equation, and then you can write it down from there. And so when I did that, I got that the quartic equation was about this. Y equals 4.24 times 10 to the negative 10th. I just wrote it out. Minus 0.01 x cubed minus 0.03 x squared plus 23.4 x minus 244.5. And all those had changed. The numbers are not pretty, but with real world data, the numbers aren't going to be pretty most of the time, and we just have to deal with that. So polynomial regression, it's just like all the other regressions we've done, except that here we saw that we can compare a couple different graphs. We could have thrown a quadratic up there with it. Maybe it's pretty close to quadratic, but with that tail one, I don't think so. Anyway, this one shouldn't be too hard. Don't forget to leave a fabulous comment, and I will see you in class.